So in this section, we're going to talk about the domain and range of the 6 trigonometric functions. So first, I want you to just consider this unit circle that we have here. And so we have an initial side, and then we're going to rotate around our ray. We have this angle theta. And so this point P that's equal to xy, so that point on our unit circle here, remember we define this to be what? We define it to be the cosine of theta, and then for the x value, and the sine of theta for the y value. So when we're talking about the domain, okay, so say, let's talk about the sine function. So the sine of theta for the unit circle, this is simply equal to y. Now, for sine, there is no concern about dividing by 0 here, okay? So there's no input of theta that I can plug in where I end up dividing by 0, which is a no-no, right? That's, one of our things that would limit our domain, right? So therefore, any angle that I can dream up, I can plug in. That angle could even be greater than 1 revolution around, right? If I went all the way around, that would be 2 pi, right? But if I go all the way around, heck, all I have to do is just keep going as many times as I desire, and then I can still compute what that angle is, okay? So, what is my domain here? The domain is all real numbers, negative infinity to infinity, okay? Negative infinity to infinity. Now, if you want, you could write this script R here. This is set notation. If it tells you to put an interval notation, this is negative infinity to positive infinity, okay? Now for the cosine function, the cosine of theta, okay, cosine is equal to x, okay? There's nowhere here that we're going to be dividing by 0, so once again, my domain, okay, the domain is all real numbers again. So all real numbers again, and you can put R if you would rather. I'll take either one of those unless it specifies on the exam to put an interval notation, okay? So the domain for the sine and the cosine function, all real numbers. No matter what angle I think of plugging in, my output is always going to be something real, okay? So that's how I always think about how to find the domain. If I plug in a real number, do I get out a real number, or is it undefined or infinity or whatever, okay? So that covers sine and cosine. What about, let's do tangent, okay? So tangent of theta, if you'll recall, tangent of theta is y over x. So is there anywhere that you might accidentally be dividing by 0? Well, that would be where x is equal to 0, right? That's a bad deal. We got to get rid of those. Well, when is x equal to 0? That's when cosine theta is equal to 0. So what do I want to do? I want to avoid values where cosine theta equals 0, okay? So where does cosine theta equal 0? Well, cosine theta is the x value, so it equals 1 here, but right here at pi over 2, it equals 0, and right down here at 3 pi over 2, it equals 0. And is that it? Only here and then here? No. I mean, theoretically, there's like infinitely many, right? So how do we come up with a solution to write all the different infinitely minis? Well, let's think about this. For sure, like we want to exclude pi over 2, right? We definitely don't want pi over, or theta to equal pi over 2. What else do we not want to have? Well, I don't want to have 3 pi over 2. Yeah, that's a bad one. But what about this? I go all the way around, that's 2 pi. And then I go another pi over 2, so that's pi over 2 plus 2 pi gives me what? 5 pi over 2? I think I'm starting to see a pattern here. It looks like odd integer multiples of pi over 2. So how do I even write this? How do I do an odd number in general? So what I would actually write, okay, so here it is, the domain. The domain here is all real numbers, negative infinity to infinity, except, okay, except what? Odd integer multiples of pi over 2. Now, what does that look like? Odd integer multiple? To make an odd number would be like 2k plus 1 times pi over 2, okay? Where k could be like 0, 1, 2, 3, and so on, right? So if I plug in 0, I get pi over 2. If I plug in 1, I get 3 pi over 2. If I plug in 2, I get 5 pi over 2, and so on forever and ever. Now you can run that game backwards too, okay? You could plug in a negative 1, and I get negative pi over 2. Remember, negative pi over 2, that would rotate us back the opposite direction, and you would still end up in that same pickle. All right. So really k is an integer, okay? So integer, kind of like a whole number, but the negatives also. Okay, so kind of a lot going on there. So the domain, basically, you know, if you're gonna try your best to do it, okay? So like pi over 2 to 3 pi over 2 union 3 pi over 2 to 5 pi over 2 union ... right? Forever and ever. And you could do like a pi over 2 to, and then go back an odd multiple. So negative pi over 2 union negative pi over 2 negative 3 pi over 2, and then union ... right? Forever and ever. That would be the domain there, okay? But that's kind of nasty to write, so this is, you know, maybe a little bit simpler to understand what's going on. Okay. So that's for tangent, all right? That's for tangent. Oh my goodness, right? So let me remove this part here. Okay. So what about the range? What about the range? Well, if I look at the range, okay, the range is the output. Okay, so the range is the output. Well, what is the range? The range is the y value, okay? That's the y value. What value that the sine function can attain, all right? So what's the biggest the y value gets? It looks like the biggest the y value gets is 1. What's the smallest the y value gets? Looks like -1. So the range runs between -1 and +1, okay? -1 and +1. And so you could write, if you wanted to, you could say like sine of theta is between -1 and 1 too. That'll work as well, right? Now that's the range. What about the range for cosine? The range for cosine, what are my x values ranging between? Well, the biggest x value I think I see here is an x value of 1. And the smallest x value I see is an x value of -1. So if that's the case, then it's the same thing. The range goes between -1 and 1 inclusive. So I can actually obtain those values. I don't get infinitely close. I actually get to that point there. Okay, so let's see if I can remove this without getting rid of good stuff. All right, cool. Now, we've done the domain and range of the sine and the cosine. The last is the range of the tangent, right? So the range of the tangent, all right, how are we going to do the range of the tangent? Well, we think about this tangent, okay? Tangent theta is equal to sine theta divided by cosine theta. Okay, sine theta divided by cosine theta. Now, as long as cosine theta doesn't equal 0. Now, the range, okay, the numerator here is stuck between -1 and 1, but so is the denominator. It's stuck between -1 and 1. Now, the interesting thing about this, okay, as this cosine value, as it gets really close to 0, if I take a number divided by something that's really close to 0, this is equal to something really big. So what do I mean by that? So take some number, okay? So take some number like maybe, I don't know, maybe 0.8872, whatever. It doesn't matter, right? It's, something between -1 and +1. And I divide it by something really small, like 0.00005, right? So that's really close to 0. And when I hit enter, that's a really big number. So theoretically, we could get infinitely close to 0, which makes this really, really big, right? So my range for my tangent function, actually it ranges, the range here for tangent is -infinity to infinity, okay? So interesting result there. The domain is all real numbers except the odd integer multiples of pi/2, right? And that's for my tangent theta. That's for my tangent theta, okay? So that covers sine, cosine, and tangent. Now, let's do, what do you want to do next? Maybe we can just be consistent. Let's do the reciprocal of sine. So the reciprocal of sine is cosecant theta. Cosecant theta is 1 over y. Is there anywhere that could produce a bad value for us? Well, if y equals 0, that's bad. So I want to avoid that. So when is y equals 0? That's when the sine of theta is equal to 0, okay? So is it possible for sine theta to be 0? I think so. Let's take this right here. I'm going to duplicate it and drag it down. Where is sine theta equal to 0? It's equal to 0 here at 0, but it's also equal to 0 at theta equal to pi. And then if I keep going all the way around, 2 pi, 3 pi, 4 pi, and so on, right? So multiples of pi here are no bueno, okay? So for the cosecant, the domain, so sine of theta is equal to 0 for theta equal to some k multiplied by pi, where k is an integer. Okay, so like, 0, k equal to 0 is an integer, pi, 2 pi, 3 pi, so on. But it also works in the other way. Negative pi gets us back to a y equals 0 over here, and so on, going that way too. Okay? So what's the domain? Domain for the cosecant is all real numbers except what? Except integer multiples of pi. Integer multiples of pi. Now, the range here for the cosecant, okay, so we got to think about this for a second. If you think about cosecant is 1 over y. Now y, the sine, what did we say? Sine was stuck between 0 or negative 1 and 1, right? So this is stuck a number that's between negative 1 and 1. Okay? So if it's negative 1, if the number is negative 1, that gives me 1 over negative 1, which is negative 1. If the number is positive 1, that gives me 1 over 1, which is positive 1. If it's 0, it's undefined, it falls apart. But pick a number between here. So like 0.5, right? If I do 1 over 0.5, guess what I get? I get a number 2. That's bigger than 1, right? So it looks like either for the range, okay? So for the range here, either, the cosecant theta is less than or equal to negative 1, or the cosecant, oh, I'm sorry, I've written this wrong. Cosecant, not cosine. Or the cosecant theta is greater than 1, okay? So what does this look like in interval notation? Negative infinity up to negative 1, union 1 to infinity. Okay, so that's the range there. All right. So you got your domain, you got your range for the cosecant. All right. Now let's do the secant now. We did blue, so I'll do blue again. Why not, huh? So secant theta, this is the reciprocal of cosine, so 1 over x. 1 over x. So as long as x doesn't equal 0, we're good to go. X is cosine theta. So where does cosine theta equal 0? It equals 0 at pi over 2 and 3 pi over 2. So odd multiples of pi over 2. Okay, so the secant, the domain here, it's all real numbers except odd multiples of pi over 2. Okay, so you know how to write this in math terms is 2k plus 1. That's an odd number, pi over 2. okay, where k is an integer. So like -2, -1, 0, 1, 2, so on, okay? All right. Now, if that's the case, and I know that cosine is stuck between -1 and 1, the same logic applies that we used up here to figure out the range. Okay, the smallest positive number you could have, okay, would be if I plugged in a 1, and that would give me 1 over 1, which is 1. But if I plugged in, maybe like, even if I plugged in like a 0.9, okay? Like if I had 1 over 0.9, that was positive. That's close to 1. That's going to get me 10 over 9, okay, the reciprocal there. Put in your calculator if you don't believe me. That's greater than 1, right? So we're just getting bigger at that point. So what does that tell me? That definitely 1 to infinity, but also if I plug in this -1 here and then anything, as long as I don't plug in 0, right, I'm trying to avoid that 0 there. So anything in that interval except for 0 is good. And I see that I can get any negative value I want that's less than or equal to -1, okay, with the appropriate theta. So this is my range, okay, very similar. The secant and the cosecant have the same range, okay? Their domains are a little bit different, but the ranges are the same, all right? And the last one is the cotangent. The cotangent, what did I use? Did I use green here? Yeah. Okay, so cotangent theta, what is that? That's x over y. So as long as y doesn't equal 0, we're good to go. Now y is sine, so sine theta not equal to 0. What did we say for sine theta not equal to 0? Okay, so theta is a pi k. All right, so as long as theta is not equal to k times pi for an integer, then we're good to go. So the domain is -infinity to +infinity, except for what? Except for integer multiples of pi, okay? Now the range here, this is where we go back to what we thought about for the tangent. The x value is the cosine, and we know cosine's anything between -1 and +1, and the sine is anything between -1 and +1. So when you look at that, okay, this numerator, this takes care of all the positive and negative numbers, okay? Now, the dividing here, if I divide by 1, then that doesn't change anything in the numerator. But if I divide by something between -1 and 1 and it's not 0, it's going to make whatever's in the numerator bigger, okay? So it can be as big as we want it to be. So this output can be anything between -infinity and +infinity, okay? So the range is all real numbers, okay? So if you want to summarize these, maybe it would be helpful to put these all in a box, to summarize. And this is, it's a lot of repetition. This class is about repetition, okay? So the more you do it, the more you write it down, the better chance you'll have of memorizing these things. These different types of functions are not going away the rest of the class, okay? All right, so let's just make a little table. So you got your function, Got your sine function. Okay, what is it? It's sine theta. Okay, what it looks like. Sine theta, and then the domain. What's the domain? It's all real numbers, negative infinity to infinity. And then the range. What's the range? It's all real numbers between -1 and +1. Boom, that's the sine function. Next up is the cosine function. Cosine function looks like this. It's the cosine of theta. Okay, so the domain, once again, is all real numbers. There's nothing you can plug in to theta that's not going to spit out some real answer. The only thing about it, when it spits out a real answer, that answer is stuck between -1 and +1. Okay? Next one I have here is the tangent. The tangent is the tan of theta. Now the tan of theta, the domain is all real numbers, except we got to throw out some bad values. Everywhere where the denominator is equal to 0, the denominator is the cosine theta, and cosine theta in a unit circle is 0 in 2 different places. But since we keep rotating around the circles infinitely many times, you can have infinitely many possible undefined areas. So I want to exclude odd integer multiples of pi over 2, okay? And the range is all real numbers, okay? Next up is the cosecant. What does it look like? CSC, theta, okay, cosecant. So what's going on here? This is all real numbers, except, okay, except what? Integer multiples of what? Pi. Integer multiples of pi, because 1 over sine is the cosecant, okay? And so sine is 0 for multiples of pi. So what values here can we have? We can have negative infinity up to -1, union, and then from 1 to infinity. Okay, from our range. The next one is the secant. And the secant is SEC theta. And this is all real numbers except for where cosine is equal to 0, which is these values here. So I'm going to throw that down there, and I'm going to change the style to orange to keep the same theme. And then once again, negative infinity up to -1, and then from 1 to infinity. Bracket includes, parentheses does not include. We can't reach infinity. Okay. One less step. I guess I'll use black here so I can use all different colors. This is the cotangent. The cotangent is written COT theta. Okay, so I can plug in all real numbers from my domain, but I need to exclude integer multiples. So I'm going to do that, change the style, and I can be anything from negative infinity to positive infinity on my range. So hopefully, seeing all that we've done in this video, summarized in one little box right here, kind of gives you, a 30,000 foot view of what's going on. All right, guys.